My name is Shaib Ibrahim. I'm a licensed professional engineer in the state of New Jersey, USA. Originally, I'm from Ghana. Um, I have been in Ghana throughout my life. I moved to the US 2019, so currently about 6 years here. So this program is organized by student body of University of Energy and Natural Resources in Ghana, my home country. So I'm happy to present this topic, navigating the future of sustainable energy, skills, systems, and the youth factor. So this topic is a very broad one. I have been able to categorize this into 4 main areas. The first one is sustainable energy. The second is skills, systems, and the youth factor. And as you can see, I have allocated 20 minutes on sustainable energy, 10 minutes for skills, and 30 minutes for question and answers. So at the end of this webinar, it is the objective that you would understand energy diversity, the emerging and large-scale renewables, important drivers or influencers of renewable energy growth, the challenges and opportunities, emerging skills that will matter most in the coming years, and how to position yourself to attract opportunities. So as a matter of introduction, I would want to give a brief talk on energy sources. Energy, as we know, is the engine of every country's growth. Without energy, every country will go back to the Stone Age. So this is very, very important topic and a driver that we would have to look at. But basically, energy is categorized into 2 main sources, which is the traditional source and then a non-conventional source. And each of these have commercial and non-commercial use. Commercial is basically for profit, and non-commercial is non-profit, but it also depends. So we'll see that. Okay, the next we'll talk about a bit about conventional or traditional energy sources. So every energy is usually defined by the source. So for instance, if you talk about a gas power plant, it is called a gas power plant because the source is a natural gas. Okay, if you talk about a nuclear power plant, it's called nuclear power plant, but it means that the source of fuel is actually nuclear. So that's how we look at it. So conventional energy sources and the commercial, we have marine diesel, heavy fuel, oil, nuclear, coal, natural gas. And the non-commercial, we have firewood and dry dung. So people still use firewood and then animal waste that is dry. So it becomes a dry dung still to produce a source of energy for them in their homes or for domestic purposes. Okay. Even though you can use firewood for commercial purposes, but not on a larger scale. So I will still categorize that under non-commercial use. The next is non-conventional energy sources. And these non-conventional energy sources is not something new, but in our current dispensation, the use has been scaled up. So it's an important topic to talk about. Commercial use, we have large-scale solar or utility-scale solar, battery energy storage system, BESS, wind farms, tidal waves, hydropower plants, and the geothermal. There are a lot of them, but I just put a list of few. In non-commercial energy, we have residential solar and battery energy storage. One may say residential solar is put under non-commercial. It also depends. So when it comes under Q&A, you can ask a question about it, why we have residential solar as non-commercial. Even though people can use solar in their homes and still sell the power back to the grid. So that is something different, but not on a larger scale. So we'll still put that as non-commercial. The main reason why people put solar in their homes is for domestic use. But if you have excess, you can sell it back to the grid and then make money from that, or use it to offset your bills. Okay, so now let's dive into the main area. The main one is sustainable energy, right? But one may ask, what is sustainable energy? Sustainable energy is the energy that is produced and used to meet today's needs without compromising the ability to meet future generations' need. So the essence of having sustainable energy is for generational thinking or generational planning. We all use energy now, and the human generation continue to procreate. So as we are all procreating, having children, then the same way that we want to educate our children and have a good future for them, in the same way we want to have energy reserve for them. So that's the essence of sustainable energy. But one may ask also, why do we need sustainable energy if everything seems okay? We rely on coal power plants, nuclear power plants, and huge power plants to provide our energy needs. So why do we need sustainable energy? Why should we worry ourselves? Yes, it is true that conventional means of producing energy is dominating the energy landscape now. But also we have to think about other factors that is affecting human being as a result of the use of conventional energy sources. So according to the World Health Organization, about 6.7 million people die every year as a result of pollution. And also 8.1 million people is estimated to have died as a result of air pollution, according to the State of Global Air Report 2024. So if you look at the image I'm sharing on my screen, you could see that even though we are talking about energy, which is an engineering stuff, but this is related to health. So engineering affects every part of our life. It could be health, it could be other economy and other stuff. So the fundamental of engineering is about public health. So we'll see that. And the main reason why we care about sustainability or providing energy from clean sources or sources that have less environmental adverse impact is because of public health. That's the primary goal. And how do we achieve this? We achieve this by increasing clean energy sources in such a way that we aim at reducing greenhouse gas emission, which is largely contributed from fossil or conventional energy sources. So the aim is to reduce greenhouse gas emission and also to minimize pollution that comes from power plants or other energy means. Also, we have to remember that conventional energy sources will not last forever. If you have oil, this will not last forever. And every country, as a matter of fact, has a quantifiable amount of oil reserve or gas reserve. So for instance, if you take, I don't have the Ghana oil reserve off my head, but definitely we have a reserve, maybe let's say for instance, maybe 1 billion metric ton of oil as a reserve. But if you think about this and then you can find, okay, we can do the calculation and know that, okay, this amount of reserve will be able to last for 10 years or 20 years or maybe 50 years. But Ghana will continue to be there for centuries. So energy source from conventional is limited. And also we want to promote accessibility, especially SDG 7, which is the United Nations Sustainable Development Goals number 7, that talks about clean energy and accessibility, and then cheap affordability as well. So, and the last point is to promote eco-friendly energy. As a matter of fact, energy from solar and wind have less impact on the environment. So that's eco-friendly. Now, the good news is that according to the International Energy Agency Global Energy Review 2025, the review for 2024 indicates that renewable energy is leading by 38%, followed by natural gas 28. So renewable 38, natural gas 28, coal is 15%, oil 11%, and nuclear is 8%. So if you take the total energy produced across the world, this is for 2024, renewables dominated. So that's a very good thing. Also, we have to think about it as renewables keep on growing up. They come with challenges, right? So we are not going to increase renewables to 38%, and if that continues 2025 and the subsequent years, this is going to influence how we produce, transmit, and actually consume energy. There's going to be consequences. But the truth is that people need their energy, people need their electricity in their homes 24/7. Nobody cares about how they get their electricity. And we all have seen this. If you are in Ghana and there's a power outage, people say doomso. So doomso is a Ghanaian language. Doomso means that doom is off and so is on. So it's like off and on, off and on. Once you lose your power, people are angry, people need their power. But also we have to remember that if you have solar, does the solar produce electricity all the time? That is the absolute no. So the challenges that comes is, number one, the intermittency and variability of renewable energy. So when the sun goes to set, okay, we don't have electricity from the solar plant, but you and I sitting in our homes, we don't care. We need our electricity. We will not spare the government, or we will not spare the stakeholders running the power grid. Let's say ECG in Ghana or Gridco or VRA. We begin to complain because we need our power. Nobody cares about the sun. And when there is a slow wind, we know that the power produced from a wind turbine is directly proportional to the keep of the speed of the wind. So if you have a slower wind, it means that the power produced will be less. And so that is a problem. Wind is dependent on the location or the place. So not every part of every country has the same amount of wind. And so you cannot deploy wind power plant in every location. So that's also a limitation. And then also hydro is also having limitation because it depends on the head of the water at the dam. So, and if you look at the power equation for producing electricity from a hydropower plant, it's proportional to the head of the dam. So if you have the height, the head is the height, right? So when the water goes down, it means that the head has reduced and the power produced will be less. Okay, another thing that will be a bigger challenge with renewable growth will be policy and then politics, right? Most people or most engineers, we care about engineering, but the bigger influencer of whatever happens in every country or every industry, it comes with policy and politics. So you could have one government today that supports renewables, and another government will just come and then change the policy, and everything changes. So this is a bigger influence. Inadequate skilled labor is also a bigger challenge for renewables. Not a lot of people have experience in renewables. And so there's going to be a high demand for people who are well skilled, who have a good amount of experience and knowledge in how renewables are designed and deployed. The other limiting factor is technology is still growing. For the past 100 years, all the electricity we produce, most of it came from conventional energy sources like coal power plants. So now that we are changing, the technology has to change and adapt. But it will take time. New new forms of technologies in terms of inverter-based resources for grid forming is on the rise. So if you know more about inverter-based resources, you know that solar uses an inverter to convert the DC power from the sunlight and then change that to AC, and then that goes to the grid. But usually an inverter, now the dominant inverter type that we use is a grid following, which means that it's always going to follow the grid. So if you put a solar plant on, the solar plant per standard and code will have to wait. The inverter has to delay by 300 seconds or 5 minutes before it's able to inject power to the grid. But think about it, the customer in their homes, they don't have patience to wait for 5 minutes. We need our power. So but grid forming inverter is something that will come and change that kind of dynamics and give more flexibility in how we deploy energy. Okay, challenges, but we have talked about sustainable energy, what it is, and then how it is growing. And everything shows that sustainable energy or renewable energy is growing. And then we talk about the challenges with that will come along with that. But also we need to think about it this way, like challenges, whenever there are challenges, it comes with opportunities. It happens in our personal life, in everything. It depends on how you look at problems. Every problem that you face in life, the other side is that if you think about it deep, it comes with opportunities. The same way with renewables, renewable is growing so fast, but it comes with challenges. And these challenges create opportunity. We all know that renewables will be needed. And this will never change, it's guaranteed. As far as human population continue to increase, as far as we continue to build businesses and build new homes, this will increase demand. And as demand is increasing, it means that these people will need energy. They will need electrical energy here. So if you need electrical energy, then you have to build more power plants to be able to meet the demand. And always, to keep a grid, you need the demand and the supply to be the same, right? And we also know that now there is high growth in AI and data center. Data centers, that is driving energy demand so well, because data centers would use a lot of cooling, and so it's because of the cooling that you know that even if you have air conditioning in your home, your electric bill is going to increase. So cooling is something that needs a lot of energy, and that is why we need even though there are challenges, but the opportunity is that there's going to be demand. And the demand is that the opportunity is that natural gas, if you look at natural gas and nuclear power plants, they take longer time to build. If you want to build a nuclear power plant, it can take you like 10 years or more. But I don't think people will want to wait for 10 years. So nuclear power plants is a long-term plan. It also has like complex processes that you have to follow a lot of regulations to comply to be able to build nuclear and gas power plants. Most coal power plants are being retired, and HFO or heavy fuel oil plants are also banned in many countries. When I used to work in Ghana, in Ghana, the power plants, AXA and Car Powership, at the beginning they were using heavy fuel oil, but because of environmental conditions, they have not changed to natural gas. They've made a lot of retrofits and then changed the plant to gas because HFO is banned. But the option is that renewables are faster to design and build as compared to having nuclear and then coal power plants. So here also it means that renewables still have the competitive advantage of being the leader of the future of energy. So that's good news for us. Okay, let's come to the second point, which is the skills. We've looked at sustainable energy. We will not be able to cover everything about sustainable energy, but this is a 1-hour webinar, and so that's the brief we can discuss. The skills here, it's very important that we build skills. Very important. And as a matter of fact, most of us, I was also a victim of that when I was in school. I thought like school was everything. Everything is about school, but that is not the case. Based on experience, nobody usually cares about school. Nobody. I like school a lot. I like to learn a lot, but nobody really cares about the knowledge in school, because the knowledge in school is different from what is happening in the real world. So in the real world is different, in school is also different, but the school is very important. So what matters is that the school usually will get you into the door, but what actually will take you very long way is the skills. So let's look at some of the skills that are very important for electrical engineers or people who are energy enthusiasts. Skilled is the differential factor. We need to build our skills. We need to, first of all, if you're starting your career, I would recommend thinking about designing. Designing gives you the foundation of everything. So if you can start your career in anything, but if you want to really understand engineering and have expertise knowledge as you progress, you need to start designing. How do we put, if you look at the power plant, how was it designed? This is a very complex process. Where does it start? Where does the concept come in? And then how do you translate the concept into a paper? And then how the paper is a drawing package. And then how do you take the drawing package and actually build the plant? So this is very important to have. And not everybody have the privilege in their career to start from designing. And yeah, for me, I thank God I had a chance to be able to get involved in designing and still continue to do design. Okay, another skill you want to think about as engineer is to look at softwares and simulation proficiency. Every designing is largely influenced by the studies that we do. So they are really interdependent. So if you think about designing something, let's say you are thinking about selecting a particular cable size, usually you have to study this based on where the cable will be installed. If the cable is going to be installed under the underground, what is the soil moisture of the ground? What will be the soil temperature there? What will be the thermal resistivity of the soil? How easy does the soil allow heat to dissipate? So all of this has to be done in a software because it's really difficult to think about it to solve with hand calculations. So industry have built like softwares that are very good, very advanced, and can do almost all scenarios. Even if the cable is going to go under the sea, we can actually study that and simulate that to know the condition of the cable to select or the cable to buy. So you don't just go to the market and buy cable, because this type of engineering is far from doing a house wiring, right? So think about softwares. You don't have to know everything, but think about at least starting from one of them. We have like ETA, PSSE, SIME, WinIGS, PSCAD, NetPlan, SKM, MATLAB, PVSys, Power Factory, Dixie Silent. Actually, it's the same thing, Power Factory and Dixie Silent, same. So, and then we have Aspen Wineline. There are a lot of softwares, but try to be on top of this. And then if you can see my screen also, I have one example that is actually showing you a simple illustration that I perform. So you can see you have several buses here, right? And then you can see you have a generator, 2 generators, and then there's 1 solar power plant here. And then I try to look at when there's a problem, a disturbance, right? An electrical disturbance or a fault around the solar plant, what will happen? So you would immediately see that when there's a fault on the bus closest to the PV plant, the voltage there will depress, right? So when the voltage depresses to 0, it means that power cannot flow. Without voltage, no flow. Just like pressure, without pressure in the tap, the water doesn't flow. So voltage drops to 0, and then you can see the next bus closer to the solar PV plant drops to like 87.1%. But traditionally, most utilities or most utilities or grid operators would want to keep the voltage at a particular range. You cannot go below a particular range. So it depends on a lot of factors. But one example I can give you is that, for instance, let's say you are in US, in Texas area, maybe ERCOT, which is the ERCOT is the one that regulates the energy market in Texas, right? So they would say, okay, if there's a problem, within 10 seconds, we want the voltage to reach 90% of the rated voltage. So 90% within 10 seconds. So if there's a fault, within 10 seconds, the voltage has to rise up to 90% or 0.9 per unit. And then that is how we understand it. So you need to understand simulation and how to actually analyze this. This is a very important skill to have. And in the industry now, getting power system engineers is very difficult. So try to learn how to use softwares, like I mentioned, and then how to do the analysis. Power system analysis engineers are tough to get. So if you are good in that, you will make a lot of money. But the money is not the main goal, right? Okay, the next is to diversify your skills or your knowledge. It's not all about engineering. Even you realize that if you work in big companies, it's not all about engineering. We have different departments. Some people are into law. We have the lawyers. We have the financial people. We have the power marketing people who understand the market. And you have to also know that electricity is not sold at the same cost throughout the day. So you have 24 hours in the day, but based on the period, based on the demand, the electricity cost can vary. So during peak hours time, you have to pay more. And then during the morning or night time, when people are sleeping and the demand is less, you pay less. So that is how it is. And then you need to understand that power marketing. So having knowledge about different areas, about how power marketing is working, how energy is actually financed. If you see a power plant that is millions of dollars or maybe billions of dollars, that money doesn't come easy. It's actually financed. And how does that project get financed? So, and even before you get it into the for it to be financed, it has to be developed in a particular way before it gets to that level. So that's a just overview. So also sustainability principles, the life cycles of electrical equipment or products and their impact on the environment. The next skill that you would want to focus on is emerging technical skills, right? Think about the power grid. How the grid works is 24/7, no stop. People use electricity 24/7, no stop. So what it means is that the power plants also work no stop. And this, you will really appreciate it if you have the opportunity in your career to work in a power plant. I had the chance to work in a power plant for about 4 years, and I have seen how it is, how we start the plant, connect it to the grid, and then how it works. It's very interesting, very, very interesting to see how things work. And you realize that the power frequency in your home is the same as the power frequency at the power plant. So what it means is that in Ghana, for instance, or many parts of the country, world use 50 hertz. The frequency at the power plant is 50 hertz. The frequency in your house is also 50 hertz, which means that the power grid is the biggest or the complex machine ever made. This is a popular say. The power grid is the biggest or the most complex machine ever made, because everybody connected in their homes, it goes through like that, through the distribution lines or the distribution network, and then the distribution network is connected to the transmission grid, and then the transmission grid is connected to the power plant. So everything is connected together. When you lose a large load, what happens is that you have a bigger load drop, and then the frequency goes up because the machines begin to run very fast. So at any particular time, the grid is a data mine. It's recording data at any particular time. With the influence or the growth of AI and machine learning, how can we use this data? Because think about it, machine learning or AI, artificial intelligence is about data, right? Taking the data and making meaning from the data and then using the data in a particular way to achieve your results. So how can we use this data to actually plan for great integration and stability, and then fault detection, and then even energy trading in regional or nations, and then in different markets? If you know, Ghana, Ivory Coast, Burkina Faso, and some other countries are interconnected. So this is interconnection. We are connected through the West African power pool. So when there's a problem in some particular grade, it will affect. So how do we get this? And then even how we sell electricity to Burkina or other countries. How do we use AI and machine learning to influence these decisions, right? Okay. The next one is also to look at skills in project management or even soft skills. Most people, I always say that they underestimate this important skill. And with the growth of AI now, it will get to a time the skill that we used to do, machines can do it, because that's the AI is just to get a data, how human beings behave, how we do things, and then you are trying to model that kind of behavior and then allow machines to actually take decisions. And computers can take decisions or run tasks faster than human beings can do, right? You can give a software maybe 1,000 pages to summarize for you, but human being, how long will you take? How long do you need to read a 1,000-page document? You need a lot of effort, right? So it will get to a time AI will take a lot of jobs, but AI will take a lot of jobs from people who don't know how to use AI. So if you're in energy, you have to think about, how do I leverage the power of AI to become more efficient? It's just like in the olden days, we don't have computers. Everything we have to write, even we do not have softwares like AutoCAD, everything we have to draw. And I remember when I was in KUST, we have to carry our big drawing boards. It was so funny. We carry our big drawing board to for electrical engineering drawing or something like that. But we have softwares to do drawing. You don't have to do hand drawing again. It's just like the same thing for power system softwares. It's not easy to do hand calculation beyond 2 buses. If you have more than 2-3 buses, and then you want to calculate this using the Jacobian matrix or Newton-Raphson, you go crazy. So software can do this. It's the same thing. Using the software did not take work from engineers. Rather, it gave work to the engineers who know how to use the software like ETAB, PSSC, PSCAD. So knowing how to use AI is the best way to go, and you don't want to be left behind. But when we talk about skills, the skills that AI cannot take is this one, is the soft skill. The soft skill, nobody can take it. Machine cannot take this so easily from you. It's about effective communication, critical thinking, a team player. There are lots of them. There are several examples of soft skills, but you need to also understand how easy can you work with people, how critical do you think to solve problems, and then how effective do you communicate with your team. This is very important in communication. How do you respond to people? Do you respond to people after several days, or do you tell them, okay, I don't know this, but give me some time to find out? So how to communicate is very important. Let's go to the next one, which is the systems. Okay, so systems, we've talked about energy, we've talked about the skills that we need, but that is not enough, right? We need systems. And for engineers, we need to understand the systems that we have and how do we understand them? How do we leverage on these systems to achieve our goals? So we talk about smart grids, right? Smart, you just look at the word. We have the grid already, but we want to make things more smart. So to make things more smart, in the olden days, when I remember when I was doing my national service with ECG, sometimes we have to drive several hours to some locations, to substations, just to pull event reports. There's a fault in a particular area, you go to the substation and then pull events from the relay, protection relay, and then come to analyze the relay to understand what actually happened, what caused the event, the fault, and then plan about maintenance or mitigation. But now we want to make things very smart. You can sit in your office and then actually have access to the substation, or actually have access to everything. So that's like taking Internet of Things, making everything behave to have like access to the internet. And this will help intelligent load management and even real-time monitoring and automation. And this will help us to improve our grid flexibility, right? It makes life easier. So this is an important system that we need to focus on. Another system, as energy people, we need to look at renewable energy is growing and microgrids. And then how do we deploy these systems to the benefit of the people? You know, having renewables, as I mentioned, is easy to deploy. It's not, I will not use the word easy, but I'll say like it's faster to design and build. So what this means is that if you have a particular village or place that is so far from the grid, it's very expensive to build these transmission towers all the way from power plant to the customers. So the benefit of this is actually building renewables closest to the people who will use it. And solar is easy for that purpose, you know. And microgrids also are very important because they provide the option, if you lose one generation, another generation kick in. So if you are using solar and let's say wind, and then you have generators, and then you have a particular demand, losing one source will reduce your energy production, and so you will have to put off some of your machines. But with microgrid, you have another source coming in. So think about the word like it's a microgrid. You can create small grids instead of relying on a bigger grid, right? Okay. And energy storage. Energy storage is very important now, especially because you have renewables growing up, and these renewables have intermittency problems. And because of this intermittency problem, batteries are very important because batteries can within a short time put into service that will offset and then balance the frequency. So for fast response frequency, if you have a solar plant and there's a shade or there's rainfall or there's snow, this is going to reduce the energy produced from the solar plant. So batteries will be there to kick in to offset that deficit. This is all at your advantage. So you need to learn the skills that matter most in this new age of AI and sustainable energy resources. Next, the last point is the youth factor, right? So the youth factor, I want to talk about the definition of a youth, but usually youth, it depends on different places. People will say somebody who is less than maybe 30 years or 29, something like that, from 15 or 14 years, within that range is a youth. So as a youth, you need to position yourself for the vast opportunities that will come as a result of the fast growing demand. Though, as I mentioned, there will always be demand. So you need to position yourself for that. Opportunities don't come and look for you. Nobody sits in their room and a company will just call them because they did not apply. or no company will give you an opportunity because you are a tall person, or you're a short person, you are a dark person, you are whatever. You would have to position yourself to get the opportunity. No, you have to know that. Yeah. And as a student, you need to start thinking about that. You need to position yourself. Don't leave yourself that opportunities will look for you. We all did that kind of mistake. We're thinking that, okay, we are in the school, I'm going to university, I'm doing electrical engineering, very important course. So when I finish, the opportunities will come. No, opportunities don't come. And sometimes you realize, depending on the country you are, you will even be you even try a lot, you write a lot of exams. These companies will call for exams, you go and write it, you never hear from them. And you follow up, you will never hear from them. I have experienced that a lot in Ghana. So take that from me. You need to know what is there. Don't be overwhelmed with the degree you are getting. For the degree is very important, but in the world of work, nobody cares about that. And even, for instance, in the US here, from my personal experience and many people I have spoken to, nobody really asks you about the school you went or the degree. Nobody, I have never seen somebody interview and ask you that about the degree. They just are interested in the work you can do. So that's why I'm saying you need to position yourself and don't be carried away with the school. School, get your grade, but think about the industry. If you are thinking about going for another education, then the school, you can be so happy about the grade, right? Also, you don't want to fail. And then you have to also collaborate with other people through organizations like Student-energy, like we have here, and then IEEE and SIGRE, a lot of industries, and be a part of the generations, the next generation that will be defining how the power infrastructure and the business models will be, and position yourself to have global impact. Try to take up some training courses to fill in some gaps. If you know that you are lacking something, try to fill in by taking some courses. I have been taking a lot of training courses, and I still have registered a lot of training courses. Some of them I have not started, I just registered and kept them. And yeah, we all need to take inventory of the skills that we have. It is something that I always recommend to people. Every Friday or weekend, Saturday, Sunday, I have set an alarm to remind me to take inventory of my skills. So inventory of your skill is, I try to write, right? I have created a big Excel sheet with the skills I have and what I want to achieve, where I am. And then I try to get, okay, did I do this? Did I achieve this? How am I improving here? So take inventory of your skills and see places where you can improve. And if you are still lacking, try to seek for help. You can get this help taking training courses or talking to other mentors. Also, try to get some certifications in the industry that shows you are somebody who is dedicated to proficiency and improve yourself. If you're in Ghana, there's professional engineer lances. There are other certifications that you can go for. There are a lot. It depends on the country you are. In the US here, the process is very, very different from different countries in Ghana and other places. So try to get something, that you can also showcase that you are somebody who is looking for development and improvement. Now it's all on us. The biggest change will not only be because of technology, but it will depend on the people. We, the people, taking continuous action every single day, and then trying to make sure that we are protecting our environment, which is the world. And remember, I started this by talking about sustainable energy, right? It is about never forgetting the future generation. So that is the importance of sustainable energy. And you have to be informed, collaborate with industry peers, right? You are in the right place, which means that you are in the right program. And so put your things together, take pieces of knowledge, and then put it together and think about what is next for you. Okay, this is a funny something. The story of the coffee machine. This is not a story I have heard from somewhere. I just try to imagine this story based on personal experience and what I have seen. I've seen that in every single office or most places, there's a coffee machine there. And then everybody goes take a coffee and enjoy. Okay, but think about it like if you are always in the, what is the essence of the coffee machine? Is it always for people to come and drink coffee and do nothing? No. So if you drink the coffee all the time and not solving problems, what do you think will happen? You'll be kicked out. So the coffee machine is just there, but the main problem is that the main issue is that, or the main focus is for you to solve problems. So be a problem solver. Look at the problems in your workplace or look at the problems in the industry. Try to solve some of them. That is how you make a difference. People who solve the biggest problem gets the biggest pay. This applies to every sector. If you are a medical doctor and you solve the biggest of the problem, you can do heart transplant, you know how to do complex surgeries of the kidney or even liver transplant. These are very complex things that needs very, very advanced knowledge and skill. So the ones who solve biggest problem gets the biggest cake. If you solve the bigger problem in your company, you get the biggest pay or the biggest money, at least, for all things being equal. So that's just it. That's the last slide I have. Thank you all for joining this presentation. I really appreciate your presence here. You can scan the QR code on the slide. It will take you to my blog website, which is Shailearning.com, where you can find some other resources. You can reach out to me there, send me a message. You can follow the people there. I share every month some technical knowledge to people to learn. Okay, so now I am done with.
Okay,
thank you. Let's have the
so
question and answer. Yeah.
Right. Thank you so much for that insightful presentation, sir. We'll now move into the Q&A session. And here's how we are going to do it. If you have a question, please use your virtual hand. Just go to the reactions, select raise hand, and then raise your hand. I'll ask you to unmute and you go ahead with your question. Or better still, you can drop your question in the chat box. Hopefully we'll get to read all of them. Okay. The floor is open now for questions.
Yeah. Okay, let's see. Okay, now question and answers. Yeah, and then also people can type in their questions. If some people can type in questions in the chat, so as somebody is speaking, Idris, you can look at the question and then maybe read it to me or the person. Some people are feeling shy to talk. They don't feel shy to talk. Okay. So what is the first question?
Hello, Shaibu. Please, can you hear me?
Yes, I can hear you. Yeah, so mention your name and then go on with the question. Yeah.
Okay, thank you very much. My name is Emmanuel Wiafe. I am an ardent follower of you on LinkedIn, and I do repost most of your posts. And I just want to say, keep on with the good works and all that you keep sharing with us. So I am an electrical engineer by profession. I've been in the industry for about 5 years. I actually work with Shailearning now, and I'm able to relate with most of the things you discussed in your presentation. But I want to ask, for a young professional who wants to be abreast with what is going on in the developed nations or countries. So for instance, it's actually one of my vision and one of my plan to one day school in the US and probably work there. I want to know, do you have any recommendation for me in terms of maybe softwares I'm supposed to know, probably for an electrical engineer? In fact, as I speak, to be honest, I have an admission in the US, which I'm looking forward to taking that opportunity. So just to ask, do you have any recommendation for me, probably softwares or any other thing that you did not mention or capture in your presentation?
Okay,
Thank you.
Thank you so much, Emmanuel. So thank you. I do appreciate your kind words, and thank you for following up. And with respect to your question, coming to the US and then schooling here, it's a great opportunity. Once you have it, I would recommend you take it. Just like the same thing when I was in Ghana, and then I was by then thinking about because I like economics, I like the money side of things. So I wanted to understand a lot of things, but I have a mentor that told me that by then I was looking at schools, and then I got the admission, and then he advised me to take the opportunity. So the same way, if you have gotten the admission, or if you're even planning about applying to schools in the US here, it's not a bad thing. It's very good. I thank my mentor for giving me the advice, for coming here, and I thank God for making things. It's not everything is so easy, but it's okay. Some of the softwares you should think about, it depends on the industry you want to work in. So for instance, when I came here, one of the students who was my senior told me that he heard that it's difficult for international students to get some job immediately after finishing. So if you have some work experience back in your home country, now you say you have experience in Ghana, that's a plus. It really helps you, but it also depends on how you position yourself. So look at the skills that you are lacking. Like I mentioned, take inventory. Which sector do you want to work in? If you want to work in the solar industry, look at what are some of the skills that are required in solar. So if you know this, you can make a list, and then out of the list of 5 of the top skills needed in the solar industry or renewable industry, you now see that, okay, I know maybe how to use ETAP for power system analysis. I know how to use PVSys for power system for PV modeling. And PVSys is like the top software to know, right? So not to keep my answer long, you need to make inventory of the skills that you need based on the industry you want to go, and then try to compensate by picking up a training course whilst you are in school. So by the time you graduate, if you are doing interview, you can now tell the interviewer that I don't know how to use PVSys 100%, but I have used it to make student projects. And then you can show them the student project. That's the same strategy I used. When I completed, getting a job wasn't so easy, but I made some projects. And then when I interviewed, after the interview, I followed up. And then following up, I sent a report of the analysis I have done. As a way of the email that you always send to the interviewer after the interview. When you are responding, try to send back all the studies you have done, maybe in PVSys, and then maybe ETAP, put a short report and send it that this is what you have done. And I did that, and I think the employer was so impressed and they gave me the job. So that's what I would say. Maybe let's go to the next question. I'll keep my answers short. Does that help you?
Thank you very much. Thank you very much, Shaibu. Yes.
Okay.
I see Ahmed has a question here. I'll just ask you to unmute in a minute.
Oh, okay. So, I can read a question from here. A question from John that says, is it a question? Okay. Yeah, hello. I can hear. Yeah, who is the next on the question?
Yes, Mr. Ibrahim, can you hear me?
Yes, I can hear you. Mention your name and let's continue with the question.
Okay, sir. My name is Qais Ahmed Raimi. I'm from Afghanistan and I work for a renewable energy company. I have MD degree in electrical and electronics department. Ibrahim, first of all, thank you so much for your nice presentation. and it will help us to enhance our knowledge and learn more about the experience you have. So my question is about the renewable energy, especially on solar power plants. Is the degree of solar radiation can affect the efficiency of solar plants? Because actually I have seen this effect whenever the solar radiation is more than 40 degrees. The solar panel efficiency will reduce. But whenever the solar radiation is lower than 40 degree, it will be okay for us, as the efficiency will introduce for the solar panels. So what will be the solution if we can increase or improve the solar panel efficiency whenever the solar radiation is more?
Yeah, so this is a very good question. Thank you, Ahmed. And a very, very technical one. So as you know, the way solar PV works, it's based on the sun irradiation, right? So the sun irradiation is different in every location, depending on where you are. So the amount of so the way the solar power plant works is that it's based on the amount of sunlight, which is the radiation, not the heat. So when the temperature goes up, if you have a higher temperature, then it will affect the efficiency of the PV plant, right? So when the temperature goes up, the voltage will drop, and when voltage drops, then that will affect the power output of the plant. So think about it like the power is equal to the voltage times current. So when voltage drops, the power will be less. In the hot areas, voltages will drop. In the colder areas, voltages will increase. So this is actually done in the preliminary design stage, where you need to look at the area, and then you need to do all the analysis considering the temperature of the area. And then based on that conditions, you'll be able to tell that, okay, my plant will be able to produce this amount, right? So that's the answer I'll give. I think is because of the heat that you are getting, and then the voltage is dropping, and that is affecting the power output of the plant. So the efficiency will be less if the power output reduces. Okay, I think we can go to the next question, right?
Thank you, Ibrahim.
Okay. Okay, next question. Yeah, anyone who has a mic can talk, I think.
Yeah, I think Rogelius, your hand is up. Please, you can go ahead.
Yeah, go ahead.
Shaib, can you hear me?
Yeah, I can hear you. Yeah, mention your name and.
Thank you for your good presentation. I'm Rogerio Simchungu, a recently graduated from University of Dar es Salaam. Like I said, my degree is still hot. I would like you to, like an advice, to what major can you recommend me for my future profession, my future professional growth?
Yeah, repeat that question again. Repeat it. Yeah.
Like a recent graduate from university.
Okay.
What major can you recommend me for my future professional growth? I learn many things in our system, machines. And what major can you recommend me for my future growth?
Okay, that's a good question also. So the first thing I will recommend is try to, first of all, after this webinar, try to make a list of which company do I want to work to, or which industry do I want to work to. And I'll talk from my personal experience when I was in my home country, Ghana. And I remember when I was in KNUST, I was telling one of my friends, my very, very good friend, I was telling him that when I graduate, I'm going to work in Tema. And by then, I did not know anyone in Tema. Tema is the industrial city of Ghana. So I said I'll work in Tema, but I did not know anyone in Tema. But I have the feeling I'll work in Tema, and I wrote it down. And I told him that I'll work in this company, like not a particular company, but I say I'll work in power generation. And then I did work in power generation. So sometimes, you see, if you write things down, it manifests. Try to write which industry do you want to work in power generation, power transmission, power distribution, or you want to go into manufacturing industry. As an electrical engineer, your opportunities are limitless. Every industry needs an electrical engineer, every single one, as far as electricity usage is concerned. So make this decision on your own by writing down which industry you want to work in. Try to even go detail. Which city do you want to work in? Try to go detail how long you want to stay there, and then try to write things. When you write it happens. I do this a lot, and sometimes I even try to write like the amount of salary I want to get, and then magically it happens. I don't know how it happens, but this is the advice I'll give you.
Thank you.
Okay, the next question. Zahir. Zahir, you have your hand up. You can ask.
Yes. Yes. Thank you for the great presentation, sir. Sir, I am Zahir Alam from India.
Okay.
Thank you for the giving me opportunity to ask and question. Sir, I follow you on LinkedIn and also look at your post you say. Sir, I am pursuing electrical engineering currently in third year. I want to go into design. So, how should I go about it, and what strategy should I follow and make it?
Okay. Thank you, Zahir, for the question. You are a third year student in India. Yeah, I have a lot of friends in India. Some of my co-workers are in India, so yeah, I can relate a lot with India. Very, very smart people, very intelligent. I would advise, if you want to go into designing, look at the software, the design softwares. Most universities have the student versions for Autodesk, and in Autodesk you can have a lot of them. You have a electrical AutoCAD, you have the AutoCAD in general, you have a lot of tools that you can look. But try to think about it, like which of the industries do you want to work in, and what tools do they use to do their designing. And AutoCAD is a very good one. Try to start from AutoCAD. It's easy to learn. There are a lot of resources on the internet you can learn from, right? And by the time you graduate, you've already learned some skills. And think about it, like I mentioned, whenever you are doing an interview, the employer doesn't really care about the school. They care about what you can do. So if you can actually demonstrate that I can use AutoCAD, I can use PSSD, I can use ETAB, I can use these important softwares, then that is what matters most to the employer, because they are thinking about solving problems. And the main reason why they are employing you is not to pay you for fun, but is to pay you to solve their problems, right? So this mindset is very important. I think that answers you, right?
Right, sir. Sir, I have joined IEEE PS 1 week ago. How can I grow from there and improve my skills also?
Yeah, with IEEE always have like the student membership. Once you are in, you can always collaborate with the student body. Try to be part of the programs they organize. They usually have like important ones. For instance, like Student Energy has organized this program for students. So try to be part of organizations and try to take leadership role. It's always good, like, not to be just a member. It's good to be a member, but become a leader. Become somebody who wants to help other people to advance and grow, and that comes in a long term with the open opportunities, right? And then once you graduate from school, try to join the graduate membership. You become a graduate member where you can collaborate more. So I think that should really help you to be able to collaborate with people in different universities for research and even other things. Okay, I think another person, Abiro Frederick.
Thank you, sir.
Okay, Frederick, let's hear from you.
Okay, so thank you once again for your insightful talk on energy related matters. So actually, I'm the communication and publicity head of Students Energy Unit chapter. And my question is, currently we are working on a project that's using machine learning to improve the dispatchability of solar PV mini grids. So like, I want to know, do you have any suggestions on how some of the things we can incorporate in our model to actually make this happen?
Yeah, so I think it depends on the kind of data. So it all goes to the data that you want to actually use, right? So try to get like a good data source, and a good data source that you can actually make meaning from that data, and then you, based on that, you know the end goal of your research. So whichever research you are doing is to solve a particular problem, but the input is as important as the end product. Like they say, the garbage in and garbage out. So the data, the input, I would advise you to focus on the input to your ML machine learning model, and then once that data is defined, then you can actually progress. I think that's a very technical question, but the simple answer is to focus on the data, get the right information to feed into your model, so that the results that will come out will be in line with what you aim at. Even though usually research doesn't aim at, the aim of research is not just to get the solution, it's just to see what will happen, right? So whatever will be the outcome, you'll be able to make analysis based on the outcome, but you want to have accurate inputs. Okay, I think that's the answer to that question.
Okay, thank you, sir.
Okay. Okay, who else?
I think we have a few in the chat. Maybe let's take
Okay, let me look at the questions in the chat. Emmanuel Annan has a question. You can ask the question, Emmanuel Annan.
Yeah, hello. I'm Emmanuel Annan from Ghana.
Okay.
Past student of ATU, and then as a project manager to Kataros Engineering. I want to ask, let's say when it comes to renewable energy, like solar, when we go to our rural areas, they are using rooftop, and as well as drinking the fallen water, the rain. So my question is, as far as we want to eradicate the fossil fuel, won't it have any impact on, let's say, rural areas drinking the falling water or the rain whilst they have installed the solar panel on the rooftop? That's my first question.
Okay. Yeah, do you have another question again?
Yeah, but let us tackle with this one, and then I'll add another one to it.
Okay, maybe other people. Okay, so this is a very, very important question, and very good observation. Very technical question indeed. And I think the solar panels, rain falling on it and dropping to the ground. You know, rainfall itself, when the rain is coming, itself is clean. But depending on the environment, when it falls on the ground or when it's closer, it can be polluted by dust or in particulate matter in the atmosphere. So yeah, the solar panel can be very dusty, just like the roofing. You know, the roof, if you have aluminum roof, the rainwater falls on it and people still drink it. And the same way, this can be polluted with dust. But in terms of it being contaminated with electrical charges or electricity, I don't think that will be the case. But the side I see will be the pollution with dust, right? But I have not read anywhere about the roofing, using rooftop solar having impact on people drinking water from the building, right? But it also depends on how contaminated it is, right? I think that would be my answer to that. But I would also try to find out about this if this is possible. So I made a note about this. Does that answer you? Maybe you can ask your second question too.
Okay, well answered. And then my second question is, when it comes to solar sizing, and let's say sizing of batteries, sizing of solar panels, and can you at least emphasize that portion for us to at least get a more idea about that side?
Yeah, this a very big this very big and cannot all be answered in this presentation, but I would give like an idea of how to size, like if you are sizing, let's say, a solar plant and the rest. It will not just be a simple calculation where, let's say, you want to build, for instance, you want to build a 50 kilowatt solar PV for your domestic use. And this, I'll explain like this. It depends on the size of the project, if it's big or if it is small. For instance, in the US here, we have like a lot of types of solar. We have residential solar, commercial solar, and then even community solar, right? And each of these is designed differently based on the standard in the National Electrical Code. So you see that the amount of details or attention you pay to a rooftop solar will not be the same as how you do for a bigger solar project. Because the impact, think about it, like the impact of a rooftop solar is only to your house. But if you are building a community solar where you will have like maybe 100 houses connecting to a particular community solar, it's called community solar because it's usually built on a particular land that belongs to the community. And then instead of building small solar plants or solar plants on people's rooftop, we actually will build it on a particular land, let's say a wasteland, or maybe a brown land, and then use the energy there to supply to the homes. The design of each of these, there are similarities, but it depends on the size. So it will not just be like, okay, the size is 50 kilowatt, and then I'm buying a 500 watt module. And so you do the division and then know the number of modules you want and the rest. Most of the design, you need to account for the conditions of the site. So conditions of the site, the most prevalent ones are the temperature of the site. If you remember, Ahmed asked a question about the efficiency of their PV plant dropping is because of the temperature. So you need to know the temperature of the site. Based on the temperature, you'll be able to size your cables. So the cable size that you pick will have a particular drop. So if you want to reduce a lot of drop, you will need to select a particular cable. And so this has to be a detailed designing. I would advise the best way is to look at all the site conditions, temperature of the site, the humidity of the site, even the height, the altitude of the site. Altitude also have impact on how plants works, right? So you need to know all of this. But also the simple answer will be depends on the size. Large scale solar, which I am more involved in large scale building, 100 megawatt up to 500 megawatt solar plant, is more detailed engineering, and it takes a lot of time and effort to do that. So that's the simple answer I think I can give on this. Okay, John, you can ask a question, John. John,
okay.
Yes.
Thank you, Engineer Shaibu. So I saw this tweet on Twitter the last time. It was talking about building solar plants on car parks instead of fields and the rest. So I wanted to know if building a solar plant using a company's car park is feasible.
Yeah, those ones are called carports. So it's the same thing. We have several types of solar. People build solar on car parks. The reason is that the car park is just a piece of land, and so you want to build a carport, and then the carport will serve two fundamental purposes. Number one is to provide, the primary goal is to provide electricity to offset, maybe the company uses a lot of electricity and they want to offset some of their bills. So they can decide to build like a carport solar, and that will offset some of their bills. At the same time, they would also be able to provide a roofing for the car. So if you are in a particular location where the temperature of the place is very high, you want to provide shade for the vehicles. So this will serve two purposes: electricity and then shade. It's not a bad thing. It's very good. If you work in a company, you can recommend them to think about that idea. Okay, the next, are you okay with that? I think Isaku can ask the next question. Isaku, yeah.
Okay, so my question is, let me give an introduction to myself before.
Okay.
I'm Isaac Abdulhak, a student of UNE and then the head of the event and outreach team, Student Energy. So my question is, here in Ghana, we do not actually practice what we teach. What is being taught, what is always being taught in class, we actually do not relate that. And then as a fresh graduate with no connection to industries, after completion, where should I start from?
Okay, yeah, that's very. This question is a very important one, and I think a lot of us, especially most people from Ghana, can relate to this. And it's the same thing that, but it depends on the country you are in. So, industry and education. So you are in the school, you'll be graduating, and then you are thinking about going to industry. And the situation in Ghana is that most of the things we learn in school, even as I mentioned earlier on, the things you usually learn in school is a bit different in how you actually implement it on the site. So if you are working, you're actually going to apply what you learn in school. It's not going to be the same thing. It's going to be how you apply your knowledge. So you will learn power system analysis, but when you get on site, that's where you demonstrate. You learn, let's say, protection. But when you get on site, you see a particular fault. Based on the knowledge you have, then you can now apply how to analyze the fault and then how to troubleshoot and then resolve it. But all of this, we have softwares to do this analysis. You just need to understand how to use the software. So the best way for you as a student is to get your way into industry by doing internship. Internship is very important. It is the only opportunity as a student you have to be able to get to an industry, learn some things, and then get something on your resume. When you graduate school, every employer wants to see you that you have worked in a particular place. It can be 3 months internship, but of course you have learned something. And then also I always advise people, when you are doing internship, use all the opportunity you have to ask the questions. Try to find a mentor or somebody at the workplace and then get closer to the person, ask the person questions. And I used to do this a lot. I'm not talking about myself, but I'll use myself for an example. When I was in ECG, there's one of their engineers there is very, very helpful, very, very great. And I always remember him, Graham. Graham was always teaching me. I always go to him, he take things and then teach me things. I did not like protection so much when I was in school, but Graham made me to love protection and I still love it. So try to get internship. If you don't get internship, try to get a national service in a very good company. And that's how you begin to build relationship. Sometimes getting employment after even national service is not guaranteed. I did my national service in ECG, but I did not work in ECG. At the time, the job that was available for me, I was lucky I got into power generation. So my advice to you is that don't leave yourself for free. Don't leave yourself like things will happen magically. You need to take the step, get internship, and then try to learn from people, try to get involved. I think that is the advice I'll give you. So let's try to see that maybe we don't exceed the time so much. If you have other questions, the presentation here I think is recorded. Yeah.
Yes. I think we allocated 30 minutes for Q&A.
So
and we did that
okay,
by
so we allocated 30 minutes. So it's
let's take a few
okay.
from
We
the,
are now past 2 minutes.
Yes.
Okay, we can take some additional question up to the 8 minutes, and then we can close. One thing I want to say is that the PowerPoint presentation, I'll put it together in a very good form, and then I'll PDF it, and I'll put it on my blog website. You can actually get it there, or maybe I'll post it on LinkedIn. You can download it on LinkedIn or download it from the website. Okay, let's see if somebody has a question. We have, I'm giving additional 8 minutes. Okay, let's see. I'm going through to see if somebody has a question and we can address that. Okay. Okay, yeah, the question somebody has is, can you please share the PowerPoint PDF here? That's what I said. So I'll share that. Right now, I'll put it together in a way that is more presentable. Maybe add a few notes somewhere else, because in the PowerPoint you don't want to have a lot of words in the slides. And then I'll PDF it. I'll put it on the website, Shailearning.com. You can always download it from there. I have additional things on power systems, stuff you can download from there. Yeah. Okay, I think if nobody has a question again, I want to say thank you. Idrisu, you can take it from here and then bring close to the end. Yeah, I'll put the website here, Shailearning.com. Okay.
There's actually a question in the chat from Otrejan. He says,
okay,
he's
can you
into
read the question?
PLC focusing on ladder logics. Does PLC really play a big role in the energy sector? If yes, how?
Yes, PLC is very important. So this
Yes,
is the
please.
website.
Say I'm into PLC.
Okay, let me read that question. It says, I mean, the PLC focusing on ladder logics. Does PLC really play a big role in energy? Yeah, PLC plays a very, very important role, even in power generation. So as you know, PLC is a programmable logic controllers, right? So this programmable logic controllers, for instance, when I was working in the power plant, we use Modicon Quantum PLCs from Schneider Electric. So you have the PLC taking signals or information from the site, the field, the sensors from the site. A lot of devices measuring temperatures, pressure, and even a lot of signals, current, voltages coming in. All of these signals are input into the PLC. And then based on that input, the PLC has been programmed to take decisions. For instance, let's say you want to measure the fuel, the temperature of the fuel. And the temperature of the fuel should be, let's say, 40 degrees Celsius. And you put in the logic that, okay, if the temperature exceeds 45, give an alarm. So the control room operator will take action. Okay, the temperature of the oil is going up. It means that it needs to be cooled. And so if it needs to be cooled, what is the next action? Maybe the PLC is actually programmed to make sure that the closed circuit circulation of maybe fresh water, or maybe the radiator from there's a radiator actually providing cooling to this, will have to increase And so, in simple and short, PLC is very important. It's used in usually in power generations. It's used in manufacturing process because it takes input, based on the input, take decisions, and then the decision will either be correction or at worst it will send an alarm to a control operator, and the control operator will take decision. And if nothing is happening at all, it will go into the next stage that the PLC might send another signal to take the device out of service or maybe shut down the plant. So in simple and short, PLC is very important skill to have. It's under automation. Okay, I think that's the last. Somebody asked.
I think that's all.
Okay.
Say you go ahead and take that last one.
Okay, I think that's all right. So we'd like to, yeah, Idris, you can bring the program to an end now, and then
Okay.
thank you all for coming. Yeah.
Well, I'd like to thank you all for those good questions. I think the end of the Q&A will actually process. So this brings us to the end of today's session. On behalf of the entire Student Energy chapter, I'd like to extend our heartfelt gratitude to you, Engineer Shaibu, for honoring our invitation and giving us a deeply insightful session. And to everyone who joined us, thank you for making the time, and let's keep engaging, sharing ideas, and building the energy future we all dream of. So until then, stay curious and passionate. Thank you and have a great day.
Thank you. Bye bye.
Bye.
It's all said and done.